So, good day, class. We'll continue the class from where we stopped last week. Okay. Today we'll be considering operating system design types and kernels. So, let's start. Okay. All right. Now, last week we went through, we discussed the various how operating systems evolved over the years, starting from the very basic analytical machine by Charles Babbage. Then we moved to the first generation that uses batch systems and the likes. Then we moved to when small-scale integration started, and we spoke about the technology of the day being time sharing and the likes. Then we moved further. Then that we spoke about multi-programming. Then till the current stage of operating system. Okay, so let's actually give operating systems a formal definition. An operating system is a program that controls the execution of application programs and acts as an interface between the user of the computer and the hardware. An operating system acts as an intermediary between the user of the computer and the computer hardware, kind of similar to the first point. And it provides an environment in which a user can execute programs in a convenient and efficient manner. Now, imagine during the times where people are using plug bugs and vacuum tubes and the likes, and on current computer systems, let's now assume you are the one that will allocate RAM by yourself. You are the one that will allocate CPU time usage by yourself. You are the one that will allocate ports by yourself. The computer will be so complex to use. Then you yourself won't be able to make a good judge of how to allocate these resources. You probably may not. Okay, you may feel this by execution, a program is supposed to require more computing time, more memory than another program. But you cannot be the judge of that. At a time when a particular program is running and it requires an input-output operation, you might not know. Because nowadays, the concept of virtual memory, whereby a program that is not currently running is stored in the secondary memory, which is a hard drive, is now in place. So that will mean that you will be manually copying programs from your hard drive into the RAM. Obviously, nobody would want that. So, operating system basically controls all of these and avoids trouble with program execution, avoids over usage of some resources or underutilization of some other resources on the computer system. So, moving on. Now, what are the tasks that the operating system actually controls? First of all, it controls the allocation and use of computer system resources among the various users and tasks. Like I said earlier on, it's supposed to control the resources like the RAM, the CPU usage, and distribute them accordingly so as not to overutilize some and underutilize the other. And make your computer efficient in terms of resource usage. Also, it provides an interface between the computer hardware and the programmer that simplifies and makes feasible for coding, creation, debugging, and application programs. Also, it provides the facilities to create, modify, and modify programs. Okay, so I have to do a little bit of modification to my slides to make it easy and correct some errors. So right. So the third point is that it provides the facilities to create and modify programs and data files using an editor. I mean, operating systems are the only reason why you could even create programs in the first place. Then they provide access to the compiler for translating the user program from high-level language to computer language. They also provide a loader program to move the compiled program code to the computer's memory for execution. And finally, they provide routines that handle the details of input and output programming. So, moving on, operating system design types. Now, there are 5 different types of different design types of operating systems. Of course, this goes way back into when operating systems started to the current operating systems that we have right now. So the first type is the batch operating system. Now, the batch operating system does not interact direct with the computer directly. Now, these are the kind of operating system that was used in the early years. Like if we compare this with the initial lecture with the first lecture that we had, you will see that batch systems came at a very early time in the history of computer system. And like I explained last week, they don't directly relate with um, the computer. What what happens is that an operator batches similar jobs together using the IBM 1401, like the one I was showing you in the diagram last week. Then after we batch similar jobs together, we put them into the programmer into the computer. Now, after the whole thing has been run, then you take it out again and take it to a small computer like the 1401 again. Then you print out your results. So, what are the advantages and disadvantages of um, this type of operating system? First, is that it is very difficult to guess or know the time required by any job to complete. Processors of the batch systems only know how long the job will, will be when it is in queue. So now, effective batching is kind of hampered with that first point. Also, most of users can, okay, sorry, okay, so that's an advantage because um, it does not it makes preempting of jobs it mitigates against preemption of jobs in the sense that so you don't have to then say worry yourself about which one should come first, which one should come last. Just put it there, the computer will take care of it. Also, multiple users can share the batch system obviously since the operator just batches them together, then you run everything at once. Then the ideal time for the batch system is very low. Yes, and that is because as you are running, another person is batching, and once the operator finishes, another person uses the system. So the computer idle time is actually very, very low. Let me call it that. That should be low. Okay, so I said that's too low. Then finally, it is easy to manage large work repeatedly in batch systems. So what are the disadvantages of batch operating systems? The first is that the computer operator should be well known with the batch systems so as to know how to gather the system, how to even know which systems are actually even similar in the first place. Otherwise, there will be trouble. Also, batch systems are hard to debug. Obviously, yes, since for each time after the jobs are batched together, the only time you can debug is after the result is out. So the programmer will have to collect the job. If there's an error, even if it's just one command that is missing, the system will still run it and require an error. So you have to still go back, go and remove the command, then bring it back again for another round of batching. Then you run. What if there's another command missing again? You keep going up like in that round table like that, which just unnecessarily stressful. Then it is sometimes costly. Obviously, in the days of when they were using this kind of system, it was very costly. Then the other jobs will have to wait for an unknown time if any job fails. So that would mean that if they are just dependent on a particular job, those ones will have to keep waiting before you can actually use before they can maybe require some results to run. So until those results are ready, those other jobs will be pending. At the time when this kind of operating system was being used, it was used in payroll systems and it was used in bank systems during the time when it was being used. Also, moving forward, there's another one called the time sharing operating system. Now, like I explained last week, in time sharing operation system, each a task is given some time to execute so that so that all the tasks work smoothly. Now, each user gets a time of CPU as they use single systems. Now you have multiple DOM terminals connecting to the system. Now the time that each task gets to execute is called phantom. Now, after this time interval is over, the operating system switches over to the next task. That's how it works. Now, the advantage of time sharing operating system is that each task gets an equal opportunity. Every task gets equal time to use on the computer machine. Now, there are less chances of duplication of software. That's because the designers of this system had it in mind to us to make sure that there is no duplication, and it's part of how it was designed. Then CPU idle time can be yes, it is actually reduced because the computer actually does not have an idle time. Everybody connected to it has a time by which it is all the jobs that are on it has a quantum of time that is assigned to it. So once that one expires, once that quantum of time expires, it moves to the next job and runs that. Then again, keep moving on like that. And later on it will still come back if a particular program has not finished its own job to still come and run it. So now, what are the disadvantages of time sharing operating system? First is reliability problem, because reliability, that's a problem actually they had during the time of the operating system. It's not very, very reliable because you are not sure what if a particular job does not finish and you skip moving to another one like that. And so what if a particular job requires so much time? So that would mean that particular job will be on the system for a very, very long time. Then secondly is one must have to take care of security and integrity of user programs and data. Yes, since it is moving all around, so the chances are it may carry along a data that belongs to a particular job onto the next job, and that could prove fatal. Then the next one is data communication problem. Yes, again, because the processor keeps moving from job to job. So if there's a data that's supposed to actually be used for a particular job and it has already left that particular job, that data might be missing. So example of operating systems that were designed on this were the Multics and the Unix operating system. Now the next is the distributed operating system. Now in distributed operating system, various autonomous interconnected computers communicate with each other using a shared communication network. Now, a distributed system possess their own memory unit and CPU. Now, various systems house some bits and bits of this operating system. Now, they all then come together and they then share their resources. That's how they work. That's how this works. Now, the advantages of this operating system is fact that failure of one will not affect the other network communication, as all systems are independent from each other. That's a very good advantage because it's more like sharing. So if one system should go off, there are others there that will take over the jobs that are being used. Or if you need to run a particular job and one system goes off, the other systems can go ahead and run that program. That since resources are being shared, computation is highly fast and durable. Yes, because you have multiple systems that are running the same job or the same task. So obviously it's kind of going to be very fast. Load on host computer reduces, yes, for the same reason, because it is distributed, it is shared. Then these systems are easily scalable as many systems can be easily added to the network. Then delay in data in processing reduces. So the disadvantages of this operating system is that failure of the main network will stop the entire communication. That's because there's still a central system in the middle. If don't confuse this with the advantage that if one of the systems that is sharing goes off, it does not affect the system. Yes,